On your calendar invite, there's 3 things there, some things that we're gonna do today. That's the wrong one. Let's see.
It was from last weekend,
There we go. Oh, is it last week? Did I post it on last week?
the one with the midterm or the.
Yeah.
Yeah.
Well, I can just bring it up, I guess, from the folder. So there's a lot of points attached to the midterm, and I mean, to me, they're kind of pleasant to look over, but the way it's gonna happen is in 2 pieces. So let me show you a little bit more about how that looks. Morning, Isaac. How'd it go last weekend? Not all weekend. You were competing and
Yeah, well, so, no, not this group, but over together. So it's pretty fun.
good. That's what I like to hear. So, just wanted to give you a heads up. This is posted. I'll repost it again so that you have it. But you have a 2-part midterm. The first part is actually just making a video, 15 to 20 minutes. If you have to go over, let me know. Like, I'd like it not to be too long, but just what this class is about, why it's different. I kind of want to hear your thoughts on the course itself. And I also love to show it to cadets who are thinking about, maybe I want to take foundation. What is that class? Forgot to show you that actually before you sign up for this class, there is a playlist with a whole bunch of previous cadets talking about this class. So you'll give that introduction to proofs, how it's different. It is different than other math classes. I know, because I remember being shocked to the system, like this is not math. This is actually math. This is what separates us from engineers. A description of the steps in the proof wiki and what the purpose of each step is, and a clean proof of a problem. You get just one problem that you have to work on, and how the proof checklist is generated to give that quality proof. We haven't really talked a lot about that proof checklist, but at the very end, there's a little checklist made by AJ Bailey, who's coming back in about a year, I think. So AJ Bailey said he didn't know what the difference between good proof and a not good proof is, and so that checklist appeared from there. So go through that checklist, make sure everything's clean. When we turn this in on October 4th, you're gonna sit in small groups and review these videos. So your grade is not going to be affected by the critiques, and you'll get critiques from me as well. So you get some feedback on the proof that you need to change. And then you'll give me a nice clean write-up of the full proof. This is actually not the latest one. Let me see if I have another one. I know I posted something this morning. Maybe. Possibly in here. There we go. And so attached to your name is a problem. So for example, this is Isaac's, Zoe's, and Josh's. I'm pretty happy that I came up with this question. I think that they're interesting questions, but you've had similar questions. So it still follows along what we've been doing in class. Develop examples, kick the tires, test if it's true, and if it isn't true, find a good counterexample. If it is true, how could you modify that sentence or that statement so that it has conditions on it that make it true? So restrictions on the sets. Maybe the sets can't have to have the same size. I don't know. Actually, I made it up, but I don't know the answer. So maybe they have to have certain qualities about them to make that true. Maybe it's one's a subset of the other, but they're not equality because you can find a counterexample. So kick the tires, test it. You have plenty of time to work on this. Don't blow off the time. These things take quite a bit of time to sit through and really work through in your mind. You kind of have to really read your problem early, and then you can think about it. It's not that you have to sit at your desk and take that time there. So think through it. Imagine examples in your head when you have those 10 minutes between meeting, or when you have to hurry up and wait and you're standing there waiting for no reason. That's a perfect time to sit there and think. Mouth open, drool hanging off, thinking about your math problem.
So I try to make them equally difficult, try to make them similar, but they're different so that I don't have to look at 15 different same proofs of the same person. And also that you guys won't either. You'll get to see what other people do, but they're similar enough that you can rely on each other for help. You have questions for that, for this? Second part of the problem is to like take that feedback and draft it into a nice proof. I'll give you some instructions of what the, we'll have it almost like a reviewer form. This is what the folks said about my proof. This is the changes I made because of it. And here's my clean proof after it. So the thing that you have at the very end should be sparkling.
The videos, are we making the video with the group too?
No, it's by yourself. Yeah. Everything's individual.
Okay, sweet. All right.
Yeah. They're not group. This not group effort. This is individual.
Yeah.
A lot of the questions on here are individual anyways, right? Yeah, so you'll get a lot of feedback. So like if you don't have a perfect thing on the first time, that's fine. If you didn't understand it, and you can always rely on me too. Text me and say, hey, I don't get this. Ask me questions. If you don't have it, if you never shot your screen before, PowerPoint will let you just shoot the screen with a PowerPoint, and you can do that. I use something called FreeCam. Make sure you close your laptops. Give me your full attention. So there's something called FreeCam. It's a free download. It's fine within the firewall of West Point, and it's super, super easy to use. I love using FreeCam because it's just easy. So you could use FreeCam if you wanted to. PowerPoint's also pretty easy, but that makes the size of the file big if you use PowerPoint. And then everybody should know how to share a file, make it editable so I can download your video. Any other questions?
And this document is on which calendar day?
I'm going to put it on today so that you have it. All right. Next thing we have to talk about is the problem we did the other day. So remember the problem that we did on the tennis players? We didn't think that one through. That includes me. So just to remind you, we had tennis players, tennis club, and you were given that it had 2 N members. How do we pair all the members for matches? That was the question. So I'm going to go through the flaw. Make sure you understand the flaw that we had a flaw in class. So let's get that internalized, and then I'll give you a fill in the blank where you're going to articulate that back towards me. All right, let's start with the picture that Garrett had on the board. So let's suppose we had 3 members. 6 members, 2 times 3 members. So he had this picture on the board with a tree. And the total number of matches that you can pair up one with is 5, right? Here's the problem. Let's say I took the match between 1 and 2. Then I go to the, then 2 is out. 2 can't be paired with someone. That was the flaw. We can't go to 2 and then pair up 2 with other people because 2 is already in the match with 1. So 1 and 2 are taken care of. The next person up for grabs is 3, and 3 could be paired to 4, 5, and 6, which is 3 matches. can't spell today. Spell check was the best invention for Dr. T. It meant I could actually write grants and papers.
Okay, so. So 1 and 2 were taken, 2's not available anymore. So the next person you go to is 3, and 3 could go to 4 and be matched to 4, 5, and 6. So there's 3 matches. Now, how do I get the total number of matches? Just if there were these 2 scenarios alone. Would I add them or multiply them? You'd actually multiply because you go, what if this one, right? What if this one? So you'd actually do it 5 times 3. Tracking? As if you have a question somewhere, I can see it.
So my saying that two is.
Because 2's taken,
Two.
right? So if let's say that this was the first match, 2's taken. She's playing number 1.
If we take 5 times 3, I think if I recall correctly, we did get 15 matches. As like our final answer. I think that's just the way we got 15.
Right, let's keep going.
We did.
The next one would be, let's say this one was taken. I'm just going to take one scenario. This one was taken, then the only other match is 5 and 6. So there's only one match left. So it'd be 5 times 3 times 1. What we didn't account for is that when I pair 2 people, they're not up for, those 2 are gone. They're not part of the next thing. So we're not going to get a 2n minus 1. We're going to get a 2n minus 2 for the next one. And then we're going to get a 2n. So we're going to get, I'm sorry, 2. So 2n minus 1 would be the first case because that's 5. So I'm going to generalize this in a second. Let me have you think about this. Alex, you're thinking about it. Maybe not here at West Point, but in civilian colleges, I used to get stressed out when I watched students taking an exam. And I walked out one day and I told somebody, hey, I'm really stressed out watching them take an exam. He said, well, it's the first time they're actually thinking. So I actually like watching them take the exam. Hopefully that's not happening here. All right, so let's generalize this. We ready for this? Ask me questions if you don't understand this. Isabella, you usually have good questions. You got it? Make sense? Okay. All right, so if I had 2 n players, if I generalize this first tree, what would I have here? What was 5 in terms of 2 times n in this case? Two n minus 1, right? So this would be 2n minus 1. And this one would be what? The second one. 2n minus 3. Dot, 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 all the way down to 1. So then if you generalized it, what you're going to get is everybody ready for me to move on to the next slide? So here's what you would get. You get 2n minus 1 would be the first one, times 2n minus 3 would be the second one, times all the way down, times, and this last one would be 2n minus 2n minus 1, so that you get plus 1 at the end. All right, so now Josh is gonna wanna know how to make this into a generalized formula. So instead of sum, the sigma notation, we use a big capital pi to represent products. So before Josh asks, what would this be? Well, my eyes, if I let my eyes start from 0, then this first one here, the numbers that are changing are these guys right here. So this first one would be 2i plus 1, because if I stuck I equals 0 into 2i plus 1, and by the way, this is how you get odd numbers. You're about to jump into number theory next. And number theory, we're always going to talk about even and odd numbers. Even numbers are always represented by 2i. Odd numbers are represented by 2i plus 1. If you took 255 or 205, I don't know how long you spend on Taylor series or sequences of series, but there you start seeing these formulas for odd and even numbers when you try to come up with your generalized sum. So I used to love those. So that's what you would get here for the first one. What would this one be here then? This would be the I equals 1 case. Let's just test that out. Kick the tires on that. See, if you have 2i plus 1 and you have I equals 0, that would give you the first subtraction. If you have I equals 1, that would give you the second subtraction. See it?
Yeah.
Right. So your formula would be 2i plus 1. And when does it stop? 2n minus 1. Such that line means such that. And this would be 2i plus 1 with I equals 1. And it would end at I equals 2n minus 1. Yes. Hang on. No, hold up. I'm not committing to that yet.
Because wouldn't the 2i plus 1 have to equal 2n minus
Correct.
times n minus 1 plus 1?
We can just check it, right? When I is 2n minus 1, and plug it in there. If I is n minus 1, sorry. And I plug it in here. Yep, I get it to work out. All right, okay. Now, if you multiply the second one, I'm pause there and let you internalize this for a second. These problems are tricky. If you took the 256, you probably had a little bit of this at the beginning of probability, where you can look in the back of the book and like any answer could have been right.
In our class, it was just like, they just started throwing it at us. We'd never seen any of it before, so they were like, here you go. And it's like, you can do this.
I never had a problem sets class, so usually I get it from people helping me. Like, if I'm helping someone, and like, oh, any answer could be right. I can make up an answer; it could be right. But they're little puzzles, and you really have to think them through. Next thing, if you have order matters, so you want to actually say, okay, person number 1 is going to play, you actually have double the amount. So I think Garrett said that, a couple of you said that in here, like you found, okay, I'm going to double the number of matches, because if 1 plays 2, then 2 could play 1. So there's 2 possibilities there. But on every single term, you have a double the matches. So you really have, if you have this guy here, if I care who serves first. Agree? But now you don't have a sum, you have a product. So you're multiplying 2 how many times? I'm starting my index from 0. This is why I dropped out of combinatorics. I wanted to start my indices from 1. My colleague wanted to start them from 0, and we broke up. Your index starts from 0, so how many times you're going to be multiplying 2 in? N times. So really, how many would you have total of this product if you multiply 2 n times? 2 to the n. 2 to the n, right? Because you have 2 times 2 times 2 times 2. So if I care who serves first, I would have two times 2n minus 1 times 2 times 2n minus 3 times dot 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 times 2 times 2n minus 1. And there's going to be n terms. So the serve first case is just going to have a 2 to the n power on the outside of that product because you already multiplied them. You can put them inside. I don't think you can put them inside the product. You have to put it outside the product. So here. That's what my formula is. That's what you get. All right, so just to reiterate, what we got wrong is that we didn't account for the fact that 2 people were taken out. If they're playing a match, both of those people are taken out. They're not part of the next tree. That's what we got wrong.
Off the slide before this, please.
Yes.